Hi guys, thanks for watching. This is the second of two pre-calc reviews, or Math 3 pre-calc reviews for the final exam. The third page, well, I will just post a photo of that in the forums, so you'll just see a static copy of that. Anyway, so here's this last one here. Where does the sine function have roots? Just kind of, we're looking for a general expression for the roots of the basic sine function. It crosses the x-axis, that's where the roots are, at 0, pi, 2 pi, 3 pi, etc. Every integer multiple of pi, in other words. So if k is just any integer, then simply stated, the roots of sine are at pi times k. Every integer multiple of pi, you'll have a 0 or a root of the sine function. The cosine function, same kind of question. It crosses the x-axis. It has its roots at pi over 2, at 3 pi over 2, and you keep going around, 5 pi over 2, 7 pi over 2, all these odd integer multiples of pi over 2. And so a kind of a clever way to say that is to say pi over 2 plus pi k. So adding any integer multiple of pi plus 1/2 of pi, that gets you a root of the cosine function. Okie dokie. Which trigonometric functions are undefined at 0 or at pi over 2? And so the cosecant and the cotangent functions are undefined at 0 because cosecant of 0, well, think about that for a second. Cosecant is 1 over the sine. And so cosecant of 0 is the same thing as 1 over the sine of 0. Well, the sine of 0 is 0. So 1 over 0 is undefined. Same thing goes for the cotangent function. Since cotangent is cosine over sine, at 0, sine equals 0. So you're taking cosine and dividing it by 0. In other words, it's undefined also. At pi over 2, on the other hand, the tangent of pi over 2 is undefined because tangent is sine over cosine. And now cosine of pi over 2 equals 0. So once again, we're dividing by 0 when you try to take the tangent of pi over 2. And same thing goes for secant, because secant is 1 divided by cosine, and cosine of pi over 2 is 0. So secant of pi over 2 equals 0. Okay, let's see. For number 4, what is the nth term? So we're looking for the equation for that, for this clearly a geometric type sequence, and you can verify that this term, 6.75, divided by negative 1.5 is negative 4.5. You could try it with a couple of others, but that's your common ratio right there, negative 4.5. So that's r. Our first term is negative 1.5, and there you go, putting them into the nth term equation for a geometric sequence. For this sequence here, what is the nth term for this one? This one is an arithmetic sequence. We're adding 5 every term. And so our structure for that looks like this. Kind of an awkward and silly way to write an equation, if you ask me, but this is how all the math books do it. And until I become king, that's probably how they're all going to keep doing it. So might as well get used to it. So that's what that one looks like. There's your a plus n minus 1 times d. Your common difference is 5. All right, so here we got a few sums here to deal with. And this is a geometric sum. We're multiplying by negative 2 for every one of these terms. And so the partial sum for a geometric series looks kind of like this. Your a times 1 minus your r to the nth power over 1 minus r. R is negative 2, which makes it a little bit awkward here to write this. But you can figure out quite easily that actually this is the 7th term. It's just doubling every time. So 5, 10, 20, 40, 80, 160, 320. So it's doubling by every term, and there's your 7th term. So we just kind of work that out. Negative 2 to the 7th is negative 128, but 1 minus negative 128 is 1 plus 128. So you do all this arithmetic, and you get a total of 215. Not too bad. Next one's even easier in my opinion, because we have this lovely little formula for an infinite sum of a geometric series. 1 divided by, or the first term divided by 1 minus r. All right, first term is 1 here. So 1 minus r, you got to figure out r. Well, that's actually pretty easy in this case. It's just 2/5. That's what we're multiplying every time. And so that's 1 over 3/5, and that makes 5/3. This one is a little bit trickier to find the term number for the term with a value of 11.875. So what you do is you set the equation, the expression here, equal to 11.875, and we're going to solve for n. Well, since n is an exponent, we're going to have to use some logarithms here. So I've kind of compacted a lot of stuff into this little space. I hope you can follow this. So I'm first dividing by this multiplier here, 6,080, on both sides. And then this will be canceled out, right? This will cancel out. And then I'll have this fraction equals 0.5 to the n minus 1, all right? Then I'm going to take the log, to solve that, I will take the logarithm of both sides. I'm using natural log, but it doesn't really matter. I'm going to take the natural log of both sides. So the natural log of this fraction will equal the natural log of 0.5 to the n minus 1. All right? Now, if you remember how to do this, your exponent here kind of swings around and becomes a coefficient of natural log of 0.5, and then we're going to divide both sides by the natural log of 0.5. Okay, so it's a little bit complicated of a process. I hope you can sort of follow my verbal description of what's happening here. Basically, I'm going to take this on my calculator, divide it by the natural log of 0.5, and that turns out to be a nice friendly 9. That equals 9 exactly. And it's important that I don't round off on this. Otherwise, I won't get 9 exactly. I'll get something pretty close to 9. So I left the fraction just expressed as it is, like this, just to keep preserve the accuracy. And so 9 equals n minus 1. That means n equals 10. This is, in fact, the 10th term of this sequence. We could have just worked it all out and counted. Let's make sure we can count correctly. All right, so the last problem here about the sums is always a little bit, tricky on the reading of these. You start out with $1,200 in January, and you want to know what your earnings were for the entire year. So that's 12 things you're adding up. It's actually the 12th term, not the 11th. And I believe I made that mistake in class today, so I'm correcting that mistake. Hope you're catching that. So there's our nth term equation, just for the heck of it. Don't really need it. But, so we're taking 1,200 times 1 minus 1.16 to the 12th power divided by 1 minus 1.16. That all equals, and some of you had this answer, and I was a little unsure, to tell you the truth, because I didn't really trust my calculator's old school algorithms on there. But anyway, the correct answer, the correct sum is $37,020.20. Okay, enjoy that. Bye-bye.